Okay, well, welcome from Aaron Smith and Nancy Bakeman at the Energy and Environmental Building Alliance. Thank you for joining us for today's webinar podcast series. Today, we'll be talking about realizing the promises of the IRA and how smart diagnostic tools can ensure heat pump energy savings. And today, we're joined by Wes, Lauren, and Joe. And with that, I'll turn it over to Lauren for some introductions. We will have a Q&A section open. Feel free to put your questions there. You can probably chat them as well. And I'll ask those questions to our panelists throughout today's presentation. But Lauren and the team, welcome.
Thanks,
Aaron.
Thank you.
Glad to be here.
Thanks for hosting us.
All right, we can get right into our introduction. So I'm Lauren Isaki Kua. I'm a systems engineer at Pacific Northwest National Lab. Most of my work with PNNL works with the Department of Energy in building energy efficiency and federal workforce development. So today I'm here representing the DOE's Smart Tools for Efficient HVAC Performance campaign, or the STEP campaign, which I'll discuss a little later in the presentation.
I'm Wes Davis, ACCA, Air Conditioning Contractors of America. I'm our Director of Technical Services, in charge of our education, code standards, and our effort to identify quality contractors.
Yeah, hi, I'm Joe. I'm with MeasureQuick. Besides being the client success manager that we have, I'm also doing training and also revamping our app, which we just did a major overhaul, especially for ACA. So we'll talk about that today. So thanks for being here, everybody.
So we're breaking our presentation here today into three main parts. First, I'll briefly discuss the Inflation Reduction Act and how the STEP campaign can help to ensure that some of the incentives that are being provided for high efficiency HVAC systems like heat pumps are actually doing their job in reducing costs and carbon emissions for households. Second part will be Wes discussing the importance of HVAC system commissioning and what the ACCA is doing in that space with its standards, as well as its quality installation program with the help of smart diagnostic tools. And then finally, Joe will be talking about the details of smart diagnostic tools like MeasureQuick and how those suite of tools really have the power to transform the residential HVAC industry with providing third-party verified system verification for HVAC performance. So first, moving on into the IRA and the STEP campaign. So as many of you know, the Inflation Reduction Act, or the IRA, was signed into law just about a year ago now. With that piece of legislation comes dozens of various programs that are really targeting reducing inflation and providing domestic investments in energy production, manufacturing, as well as carbon emissions reductions. So two of those programs coming out of the Department of Energy are rebate programs targeting residential buildings and providing rebates for upgrades in energy efficiency as well as electrification. So those two are the High Efficiency Electric Home Rebate Program and the Home Energy Performance-Based Whole House Rebates Program. And there's a whole suite of upgrades that are eligible for rebates, one being high efficiency HVAC systems like electric heat pumps. Now, while it is the goal of these residential rebate programs from the IRA to ultimately save American households in energy and utility costs while also providing indoor air comfort, a simple swap out of older, less efficient systems might not actually guarantee the savings that the IRA is really going after. A recent study done by the Department of Energy's EERE in 2019 was a meta-analysis of existing literature on HVAC installation practices, and it found that anywhere between 70 up to 90% of air source heat pumps and central air conditioners in residential homes have at least one energy wasting fault, and that's due primarily to improper installation. So it's pretty staggering. Basically, a lot of our HVAC systems in residential buildings aren't performing as we're expecting them to. And this is primarily due to improper installation and a lack of quality control, which is leading to poor performing HVAC systems at a cost of about 9% national residential HVAC energy waste. This figure here is from a 2020 study from Winkler and others that looked at residential heat pumps and air conditioners in single family homes. And it's a modeled estimate that used fault probability distributions from existing field data. And this table right here is from that previously mentioned EERE study, just mentioning the primary fault types that are found in residential buildings. So improper equipment sizing, improper airflow, improper refrigerant charge, and duct leakage, which are leading a lot of these systems to test outside of the recommended range for optimal system performance. So this obviously has major implications for the IRA's residential rebates that we're talking about. We're probably expecting thousands of heat pumps and high efficiency ACs to be installed as a result of these financial incentives. But if they're not done correctly, then we're not going to really be seeing the savings that we're expecting. So one way that we can ensure that the systems are installed correctly from the start is by providing quality assurance. And the State and Community Energy Programs Office from the Department of Energy is actually providing some of those program requirements and application instructions to individual state energy offices, which are charged with administering these rebate programs. So this document just was released this year. And I just wanted to highlight the two sections from that document of program requirements. So they're really having a focus on protecting consumers through quality assurance. These are 3.2.5 and 4.2.5 from that document. The text is basically identical for both of these rebate programs. And I just pulled out the two relevant requirements for HVAC systems. So requiring post-installation photos of any major upgrades for homes, as well as providing a proof of commissioning on HVAC equipment. And one way that state energy offices might consider streamlining this process of collecting these required data points is through the use of smart diagnostic tools. Which leads me to our campaign from the Department of Energy. So the Smart Tools for Efficient HVAC Performance campaign, which I'm here representing today. Its main goal is to overall increase the adoption of smart diagnostic tools in the HVAC industry to help streamline system commissioning, as well as ensure residential HVAC installation quality. As a campaign overall, we have our main efforts being partnering with various entities and organizations to increase the impact of their existing programs or starting new programs that can really benefit from the use of smart diagnostic tools. Second is we provide technical support and resources to anyone interested in learning more about smart diagnostic tools and how they can use them. And finally, we like to recognize key stakeholders and early adopters of these tools who are really increasing visibility of the benefits of smart diagnostic tools. So we're in our second year. We found that two of the main stakeholders that we really want to partner with to get this off the ground with are first contractors, who are the ones installing HVAC systems, and second, training organizations who have the ability to train contractors, technicians to be able to expertly use these tools and switch over from more analog methods. This year, the STEP campaign is recognizing these 4 different organizations across the country who are early adopters of these tools in their training programs. So we have Frontier Energy and iHockey's pilot program called the Career Pathways to Advance the Trades in HVAC Services, or the PATHS program in Inland Empire of California. They're integrating the use of smart diagnostic tools in their workforce development program curriculum. Second, we have Johnstone Supply. They are a wholesale distributor of HVAC equipment across the nation, but specifically their Denver, Colorado office provides a smart diagnostic tool training program available to HVAC technicians across the country. Smart Local 265 is a union in Carroll Stream, Illinois. They provide an HVAC apprenticeship program that also integrates the use of smart tools in their curriculum. And finally, Portage Lake Center HVAC program in Uniontown, Ohio, provides a suite of tools up to $2,000 worth for all of their students, and includes smart tools, and they integrate that within their curriculum as well. We're also recognizing 4 contractors who are early adopters and piloting ACCA's quality installation certificate, which Wes will talk a little bit more about. So that's Eco Plumbers, Jackson Comfort Services, Ray O'Cook Heating and Air, and Simpson Salute Heating and Air. So we're really appreciative to all of these organizations and businesses who are really pushing forward the use of smart diagnostic tools in the industry. Next, I'll pass it over to Wes.
Perfect. Thank you, Lauren. So I want to thank Lauren for teeing up and setting the table on why it's important for us to get HVAC system installations right. The DOE research, very important, and this is what is leading ACCA to recognize quality contractors and identify quality installations that are delivering on their performance and comfort promises. So as Lauren set up, next slide, please. As Lauren set up with the DOE research, a friend of mine recently retired, maybe not so recent anymore, from the EPA, Chandler von Schroeder, eloquently stated it this way. He said, if you ordered a pizza and you open the box and a huge chunk of it's missing, you'd go ballistic, be on the phone with a pizza parlor. Today, there are thousands of HVAC systems that are being installed or replacements being installed, and they've got a huge performance chunk missing from their capacity, from their performance, and that has efficiency impacts. And that's a big problem. A bigger problem is that there are a lot of HVAC companies that don't know that that's happening. They're unaware. HVAC owners are notorious for relying on their best technicians, the guys who are probably the most technically competent in their companies, to go out and do these installations. They spot check them and no one complains, so they must be doing things right. Right? Well, that's the problem. We want to make sure that those systems are being installed, because if they're not, it leads to callbacks, warranty claims, and customer issues, which affect their bottom line, the builder's bottom line, and everybody's reputation. In 2009, Energy Star came to ACCA and said, we want you to be a gatekeeper and identify contractors, HVAC companies who can install systems in our homes and make sure that they do it right. And we said, no. We had no way to verify that the equipment was being installed correctly or business operations were being performed correctly. So we said, thank you, no. Well, I don't think they got any other takers. And so they came back, and we were happy to say, I tell you what we can do. We can identify some minimum requirements that the company needs to meet, ensure that they are willing to submit to oversight, and then work with PERS raters to verify the design, make sure that it's done correctly, and then do some light performance testing to evaluate system operation. And then ACCA will do site visits to the contractors and will ensure that they're complying with policies, and also do a subsample of data review, the file review of those. And then if there's problems, if we identify those, then we'll take corrective action with those companies. Why am I telling you this? The reason is because Energy Star realized that quality installation is important. It's vital to a new home's performance. And so they wanted to take the steps to make sure that it was done correctly. ACCA and EPA aren't the only ones. Homeowners and home builders know that comfort is important. They also know they're about to spend several $1,000s to either have a new system installed or replaced, and they want to make sure that that job is done correctly. So everybody wants comfort. They want the most value for their dollar, and they often come to ACCA for assistance. These are two ACCA websites, two of our most popular. The one on the right indicates that they're a member of our trade association. The one on the left indicates that the company has met some minimum requirements and made a commitment to quality installation. There are a lot of people who come and visit these two websites. They're probably two of our most popular websites. And in my opinion, the reason they come is they're looking for someone who's technically competent and that can do the work correctly. I think it's great that we've got a place where we can identify people who have joined the world's best trade association. I may be a little biased, or that they've made a commitment to delivering quality, or both. But we really want more. We want to take this a step further. And so we are interested in the next phase. And Mr. Deming, Mr. Quality Control, said that if you can't describe what you're doing as a process, then you don't know what you're doing. And so I use it as a lead-in for ACCA's basic design and commissioning process. It starts with the load. How much heating and cooling do I need? How large should that equipment be, or small does it need to be to provide that heating and cooling? And then for a forced air system, how do I distribute that heated and cooled air? And then last but not least is our commissioning standard, our HVAC quality installation. And I'd like to touch on each of these briefly. So the first is Manual J, and this is not a Manual J, but there are several rules of thumb that are almost as bad as this out there. So how would you know if your HVAC company was correctly modeling your home and calculating the heating and cooling loads? Well, I think there's 3 ways you could check: a good, better, and best way. The good way is you could ask them, did you do a Manual J? Absolutely, sure did. A better way is to collect a simple document, the Manual J1 report, or a J. There are several reports from different software companies. And what's important is to ask for one. And then you don't need to be an expert at evaluating a Manual J load calculation, although if you want to learn, we're happy to teach you. But you can look at a few things. Is it your address or the right model home address on the Manual J? Look at things like floor area or window area. Do they match the home that's either being built or has been built? And then last but not least, it's better. The best way, in my opinion, is to have someone that knows loads and knows plans and look and see if the home that's being built or was built is accurately modeled in the Manual J software. Next is equipment. Getting the correct size equipment is very important. You want to make sure you have enough capacity. But in humid climates, if you've got excess cooling capacity, that can create real problems as well. Comfort complaints from cool but damp spaces are clammy. It doesn't feel comfortable. And oversized equipment in humid climates can often lead to fuzzy biological growths that nobody wants or needs. In all climates, oversized equipment leads to excessive starts and stops. This extra wear on the equipment is bad and inhibits its performance, and it's not its performance, but its lifespan. Equipment, HVAC equipment's made to run. And like highway miles for your car, it's meant to go and have a nice long run cycle, especially during the summer months, or for furnaces in the winter months. So how do we check and make sure that the equipment was sized correctly? Well, once again, you could ask, and they'll tell you if they did or didn't, I'm sure. Or you could do something as simple as ask for the performance data. This is an indication that at least they have the information necessary to correctly size the equipment to the manual size tolerances. Better way, or the best way, excuse me, would be for someone who can look at the loads and look at the performance data and make sure that the equipment is going to be sufficient without being unnecessarily oversized. Next is the duct design. We've got to make sure we get that conditioned air to the right spot. But unless I have a room-by-room load calculation and the blower table from the performance data, it's difficult to assess how much air I need to put in each room and then how large I need to make the duct to carry that air. How do I verify that this was done? So the easy way, you could ask. A better way, you could ask for a duct sketch, and to tell you the truth, if it was the previous duct sketch, that would be fine as long as it was based on the loads, and the friction rate worksheet, which is illustrated above. If you ask for those two documents, again, like the performance data, it's an indication that the procedure was done correctly. The best way would be to have someone that can look at the plans and the friction rate worksheet and assess if it was actually the ducts were actually sized correctly. Last but not least, commissioning. And I've got nothing against writing something on a napkin if that's all you've got. It's not the best way to do it, but if you're at least documenting the correct information, it's a step in the right direction. However, refrigerant line, cold, airflow, yes. And then for extra credit, it was cold in heating or cold in the air conditioning mode, and it was warm in the heating mode. There's too many handometers out there being used to commission HVAC systems. Probably not as many as there used to be. I think we're making strides. But it's important to get this done right as well. And so you can ask, you could also, a better way, there's a startup checklist in the back of every set of installation instructions. If you collected that and made sure that the data points were filled in, at least you have a document. The better way, the best way, excuse me, is to commission the system. And ACCA and MeasureQuick have teamed up. We have a way to evaluate digitally, objectively, data from the system to tell us if the airflow, refrigerant charge, combustion efficiency, if a furnace is installed, and electrical requirements are all within the specified tolerance. And then for consumers, we have a very simple, easy to read, easy to understand certificate that demonstrates compliance is met. And I'm going to leave you with a couple of Deming nuggets. As builders or as people, as program managers, if you haven't evaluated, if you haven't measured, then you don't necessarily know where the shortcomings are. And without those measurements, without that data, then your guess is just about as good as the next person's guess. And so the solution ACCA believes is to use objective commissioning tools, and the person who's going to walk us through that is Mr. Joe Medosh.
Okay, here we go. So there are a lot of studies, more studies than I think anybody could imagine, that have been trying to track installations and even some service about airflow and refrigerant charge, and trying to determine if they are accurate or correct. And these go back to, as far as I could kind of track down, 1995. All right, John Proctor's been running around the country doing lots of these types of studies for a long, long time, and others. And so I have actually a laundry list of these types of studies. So most of them are were on a typewriter, so they're actually hard to actually dig through some of the data. But since then, we've had lots of other studies. So this is one of the ones that complemented what Lauren had said in the beginning. So, you know, there's an enormous amount of energy that's being lost. That's probably one of the reasons why we try to the government tried to put together this bill. But on the next slide, I'll actually show you where it actually is impacting a lot of people, especially in the West. So where we calculated this is that the amount of water that's being used for energy that's wasted in poorly systems, then we realized that it's 8.5 trillion gallons of water that's used for energy but wasted for energy. So we really wanted to highlight that, this isn't just like, well, we have the energy, we're just kind of using it already. The reality is that this is actually impacting the West, all the Western states that are using water as energy more than I think they're actually acknowledging. So we can kill kind of two birds with one stone here: water conservation and use less energy, all in the same path. So Building America is releasing, they have a pre-release kind of here that's kind of giving us some information. They're still trying to dive through this. So what they did was they did a study of a variety of homes using MeasureQuick and not MeasureQuick, and using other studies to compare how well things were going. And so they found here, you can see in the researchers determined only 23% of systems tested were charged perfectly. The rest were kind of close, but it doesn't take much. I have a chart later showing you that 5% out of charge can be a major energy waste, right? So these things are really impacting us, even though we just kind of accept that the air is cool enough. I'm okay to work with it. Most of these things are actually all based upon air conditioning or even heat pumps, and heat pumps are now clearly the way we're going. So they're much more hypersensitive as to the charge. Air conditioners, we kind of could get away with a little bit, but not with heat pumps. We're going to really find that these are critical charge units. Next slide. And ACA was in this list. So you can find this on the news. It was August 7th. There's a link at the bottom of most of my slides where you can find all this information. So, and they really talk about ACA. And there's actually a quote from Wes, the Wes believes in what we're doing and all that kind of stuff. So way to go, Wes. So it's just talking about the QI standard. And the challenge with the QI standard is that a lot of people like mention it, talk about it, but don't really do it. It is a high level. It is, the ultimate way to you can actually do an install and make sure that not just the equipment was installed correctly, but the entire system was installed correctly. So it had a fully designed, it was implemented, and now what we're able to do is go to Measure Quick and actually combine these two. So right now we have this verified system performance, which is really the QI5, and it requires some additional steps to go along with that. So there you go. So we have you must do a duct test, you must do airflow measurements, and you must do balancing. So there are a couple of methods you could do, but we're kind of particular about some of the ones you see here as to what they are. You also can get an Energy Star verified HVAC install, even for an existing home, which I think is a major opportunity for a lot of contractors who are trying to give the best they can. Like, hey, wouldn't you like to have an Energy Star certified equipment installed in your house as a replacement? It isn't just for new homes that can get this. The other thing we realize is that the industry is still looking for one other path that may not be as intense as the full QI process of a verified system performance. That we created this concept. Wait, go back one second. So we created this process of the verified equipment operation, right? This is actually just using Measure Quick and all the measurements that we do on a high level, meaning that you must have a perfect score from us and a perfect subsystem review. And this could actually work on an existing unit as well as a new install. The reality is that somebody's unit may die on Monday and they clearly need a unit the next day. You have one in your shop, but you may not have time to do a full design and do a full commissioning because they want to have this up and running. So it kind of gives you a plan B. It's like, you know what, this is the best I can do and as fast as I can do it. So this verified equipment operation, we think is going to be a major game changer throughout the industry in terms of actually being able to at least get people used to doing a much more detailed analysis, getting used to working with the QI standards that ACA has. And we still were trying to require a few things like, the matching of the equipment and stuff like that. But in general, I think this is going to be a major player for what we're doing. So there's a lot of stuff that between the standard process and smart probes, and I took a different route. I kind of went with here's how bad we're doing, and here's the things that we could be doing right. So it's easy to think of these smart probes as they're cool. Everybody wants to use them. They're great. Older technicians do not. They do not like anything that change. We don't like change as a species in general. So they're not fond of doing these things. They're like, no. I got my gauges. I'm good to go. But the younger generation, which we need more younger technicians to get involved in the industry. These smart probes are a major game changer. They're using their apps. They're all over their phone all the time. Now they're able to just feel some excitement about what they're doing in their industry, as well as we are able to teach them how to become better technicians while they're actually doing their job in the apps themselves. So these are major changes on what technicians are doing, especially entering the field. No longer need to be trained as long as they did in the past, and actually can have remote verification. Actually, somebody else can help them with what they're seeing on their app while they're back in the office to guide them through. Okay. So go ahead. Yeah. One of the issues is we're also transitioning out of the refrigerant. So we had a R22 for a while, and that had actually issues with ozone depletion. So they're like, oh, we need to find a better refrigerant, and it has less ozone depletion, but it actually is impacting global warming. So like, oh, we need to get another refrigerant, and it's always a challenge and an impact that we can find something that does well. for giving us good SEER ratings and also trying not to like devastate the planet. So this is one of the challenges that 410A has. And I'm going to go through a few things that why this is so significant. So one cylinder, and I'm going to use the cylinder as a reference for a few slides here. So one cylinder, and how we do global warming potential is equivalent to CO2. We know that more CO2 in the atmosphere makes things worse, makes things hotter. So this is equivalent to having an enormous amount of CO2 from one canister. So this is what's the impact of the canister. So if you let the canister just go, that's the impact that it has, and that's the potential. And we'll talk about how we actually do this in little bits and pieces for quite a while. It's 2,088 times worse than one CO2 equivalent. So if you have one issue of global warming of CO2, the refrigerant 410A is 2,088 times more. So 1 to 1 shows you the exponential part that goes here. So if you went to your doctor and they were using some of these tools, right, would you be confident in their findings? Maybe the 1931
Joe,
still, yeah.
Joe, should we advance? Maybe I'm just seeing the ACA QI verified still, but do we need to advance the slide at all?
No, so I couldn't see them either for a while when Lauren was speaking, and I had to kind of change my view a few times, but I'm actually seeing that they're going forward. If we
Okay.
can get a
All
chat
right,
in the
good.
background. Yeah, I think
It's
it's just a
just me.
glitch. And yeah, it
No
is
problem.
just you, Aaron.
It's the
User.
it's the Mac users, right?
Wes, are you
Yeah.
seeing the slides progress?
Oh, there we
Yeah.
go. What
Yeah.
tools
Yeah.
are you using? I see.
All right.
Yes, that's right. I change the view every now and then to try to update it or change the size of your window.
Thank you. Sorry.
Yeah, no problem. All good. Thanks. If you went to your doctor and they were using one of these stethoscopes, you would be like, wow, especially the one in the middles in there, like, the two-sided one. So these are really a strong analogy of what we're doing in our industry, that we are actually using stuff that really is from last century. And they still kind of come around. They're kind of legacy tools. Okay. So this is the same concept, that we're actually using something that has this same ability to get us close. I can tell your heart's beating. I couldn't tell if you have rhythmic issues or anything like that. I can't tell you if you're actually are 100% charged. These have a huge range in the reading. So we'll kind of go through that. So I want to try and scare everybody briefly with what's actually happening with using these traditional systems. And every time you see somebody who's doing an AC system, these are what they're probably using for the most part. So how much is in the hose and the issues with the hose. So I'm going to go through all those things you see on the screen there. I try to read my slides because you can read them faster than I could. So we'll move on. So if I have an average line set that's 5 feet, and in that line set is about 0.2 ounce per foot, that adds up to about 1 ounce in the line set. And if you're doing an exchange, like you're actually adding refrigerant, or then you actually have 2 line sets. You actually have the one that's measuring and also adding it. So, and I found out that we are through the AHRI database, that there's about 10,300 plus actually systems that are sold. We're assuming that they are installed per year. So when you go through the amount of refrigerant that's left in these little hoses, all the times that people are doing stuff, it adds up significantly. That in general, so I try to calculate the ounces to pounds of 410A refrigerant, and then convert that to cylinders, because each cylinder is 25 pounds. So that's 25,750 pounds of refrigerant that's actually lost because it's left inside the hoses. And it would seem as though that's a huge dramatic impact, and it is. So, but let's just talk about service, because service is much more, because in order to find out that that system needed to be replaced, it was serviced. So I did some rough math of saying there was about 400,000 contractors. Maybe they do 2 jobs a day, which is actually very low. And how many days a week can they work? But when you get into heat pumps, you actually will be working most of the year. So it's not just during the seasonal time. So if I've got 104 million service calls a year, there's a lot of refrigerant that's being left in these. And so it isn't as though, I'll explain why, that the refrigerant stays in the tubes, in the hoses, and gets used on the next job. That's not how they work, actually. So in general, you can see the total here of 25,000, 260,000. That's a total of, I think I did my math wrong. Anyway, 285,000 cylinders a year are lost because we're using old technology. So this also impacts the fact that they're not being charged correctly. And there's other things about the gauges, which we'll go ahead and get into, that don't allow you to read these. All these things are impacting our energy use and impacting how the systems are performing. Go ahead. Oh, the sound was off. I'll do it again. So I go, is what happens. There was actually, it's a little video that has the somebody losing their refrigerant. So there you go. This is the equivalent. The EPA's got this nice little site, says, okay, tell us about how many hydrofluorocarbons that you're using, and they'll tell you what it actually equates to. And that's a lot. You know, it's 5,000 plus vehicles driven for a whole year, or 60 million miles, or 4,500 plus homes for electric. And I thought the great one was 26 million pounds of coal burned. That's equivalent to what's happening. So in the propane cylinders, well, that's kind of ironic. So, but anyway, the point is it's impacting stuff. So we talked earlier about the challenge with the charge. So if I'm losing a little bit on each one of my charge, every time somebody connects their gauges, because they always have to connect their gauges, psh, 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 happens. It doesn't take much to either have the amount of refrigerant left in the hoses and a little bit that's kind of lost. So at 2%, which is most of what happens in just 1 or 2 times visiting the house inside the hoses, 2% is equivalent to about a 6 to 7% decrease efficiency by just servicing the equipment. And you can see earlier that I talked about the study that shows that in general, most systems were within 5%. 5% is almost a 15% decrease in efficiency. So the charge and the airflow are critical. And if we're just kind of doing good enough, you can see that we're not going to get to our goals of trying to reduce energy efficiency, and also the other impacts that are happening from global warming and things like that. So I always have the resources at the bottom. You can do that. So I don't know if anybody realizes that all these hoses that are out there, they've got little holes in them so that they don't blow up or explode in case you have too much pressure in them. So they got these little tiny pinpricks in them, and it's intended to make sure that the gas, again, doesn't overload the hose. But then when it's turned off, even if you've got these low loss fittings, they're actually a fitting that actually trying to keep everything inside at the connection so it doesn't just bleed out when you open the tube up. It still is allowing a lot of things. So if you did that, and you probably by the next day, most of that refrigerant did not stay in there. And if it's much longer, it worked its way out of the hoses. So we're not keeping stuff inside the hoses. That's the whole point of this concept, is not only the hoses are not correct, but also the accuracy that's happening here. So what is that measurement? There's a thing called a parallax error, that if you're looking at something with a needle, depending on how far away the needle is from what you're reading, could actually give you an entire skewed version of what's happening there. So you can see on the right, they're talking about a temperature gauge, and what you're reading here, it's the same for actually a refrigerant gauge, as to when if you're not looking at it straight on, and the shadow should be directly behind the needle, then you may not be reading it exactly what it is. So go ahead and go to the next slide. And those needles are huge. That pink area is the 410A refrigerant. So if you're really trying to figure out what that is, you're not going to be going, oh yeah, I think that temperature is 106.3. You're just going, yeah. A lot of technicians are like, it's in that range. It's that 11 o'clock kind of number that I'm after. So you can see now where these things are actually gotten us in a lot of trouble in terms of actually having critical measurements. And there's a huge measurement insert. I actually took a few slides out because I was worried about time. But if you see what you're reading on the other side, plus or minus 3 or plus or minus 8 psi, and how that's getting extrapolated in these K-type measurements that you're doing for your temperatures, plus or minus 7. So if you start adding these uncertainties up, it's really difficult to know that your charge is correct. You have to be dead on exactly what the number should be, as best you could conclude that you actually have the correct charge as part of your process. Meanwhile, all of these great new smart probes are amazing at giving us, nothing is dead on accurate. Everything has a plus or minus, but these have an accuracy that gives us a high confidence that this is actually what my number should be. And they're actually using to a fraction of either a single decimal, if not 2, that's being rounded up. So we know that we're getting accurate measurements with these great devices. There's also the issue of these hoses and cross-contamination, because now we're headed down this path of multiple refrigerants. So if we're not cautious about how this happens, that if you combine refrigerants, not only does it degrade the equipment, it also degrades the efficiency. So we've been kind of doing fine with 410A. Everything's 410A. We've been living with that for many, many years. It's rare to see something that's R22, and if so, you're probably going to be figuring out a way to replace it. But now we're bringing on R32 and 45 4B and Carrier, and everybody has their own, sometimes proprietary refrigerants. So this is going to be a challenge. In theory, if you're still going to stick with these gauges, you have to have a gauge for each refrigerant so that you don't end up doing cross-contamination. And that's not common in the industry that people are willing to put that kind of money in. So you're better off to just put money into a smart probe or something that actually is not going to increase contamination. I'm not going to deny that when you hook up any kind of gauge, whether it's a smart probe or not, you're still going to get a little psh, psh, that happens, but it's a whole lot less than leaving a refrigerant in a 5-foot hose. And let's kind of talk about calibration. So these things also need to be calibrated. And of course, like the old Magnehelic manometers, they also have their own little like screw hole to make sure that they're doing correctly. And these guys take special care of these devices. They're not being knocked around or thrown in the back of the truck or anything that could cause them to be not calibrated. But here's the whole kind of process of calibrating it. So if you're going to think that you can calibrate it at each job, that's kind of crazy. In fact, I have the link to the video. And this guy, Dr. Zarkarloff, was very frustrated about trying to get that cover back on in the fourth picture. So it's not an easy thing to just always calibrate. Here we go. These things come out of the box, calibrated. They're ready to go based upon any elevation. And it's it. There's nothing to mess with or confirm or change or even do in the app. We now have the intelligent designers and people behind these things knowing what are the challenges in the field, so we now can see that this is where we're headed and this is what people need to have in their hand, reduce loss, accurate readings, and allow us to get the stuff we need for these types of programs. So a lot of people still thought, well, I need to see my gauges, I want to know what those look like. And so we actually have some gauges that look like the old gauges to make people feel comfort, like having their teddy bear in front of them. And other gauges are still converted to digital numbers. These are the manifold type of process. Very common. A lot of guys love their manifold. And they also have the ability to do temperatures and a variety of stuff that's not just the individual probes, but we still have hoses. We still have refrigerant loss. We still have those kind of issues. And these things have no real direct reporting system. Even if you take a picture, it's not that accurate. So Fieldpiece, MeasureQuick, all of these manufacturers have these great abilities to generate a report and provide you with the information you need. Many of these are could be a screenshot that's better than nothing. That's getting me the fact that I was there and I did this information. Others are actually creating a document and saving all the measurements to their cloud or generating a report that anybody else could see. Many other apps can now talk to these PDFs once they're generated, so I can pull information out of them. And you can actually see for sure when it was done, who did it, where they did it, what tools were they using, and what were their actual measurements to conclude what their results were. This is what will make the IRA successful. If you're not going to really commit to getting these type of accurate and accountable measurements, we're just destined for failure. So on that caveat, how smart are these probes? Because these two psychrometers are giving me temperatures and humidity, but so are those little analog gauges in the middle. The issue that we're having is that what should the temperatures be? It's one thing to measure something. If I don't know what it should be, I can't act accordingly. So on the left is the Testo app. A lot of apps just give you the direct information from the probes. Not all of them also compensate for altitude for other pressures that you do for measuring static pressure. But we try to accommodate that in MeasureQuick. So MeasureQuick is not just giving you the values you see on the bottom right, but also telling you what your target is and what's your allowable range and are you in that. So you can see it on the gauge. Here's my split. And if I tap on that actual individual gauge, it actually pops up this screen you see on the right. So the more failures you have, the more problems clearly the system has. So the more I can identify them quickly and move through them, then I can correct them right there at the install or even at the service. Not everything needs to get replaced. The goal is, can we actually do accurate measurements, determine the cause, correct it, or recommend replacement? And the goal isn't to just replace anything that we show up for. So some of the other things that we have all of these refrigerants. You can see the line effect. I probably will not be able to finish talking before we get to the bottom of them. But you have to correct for altitude for these. and there's a center of the glide for a blend. Like 410A is a blend. It's two different refrigerants. So you have to know what you're doing in terms of calculating that. So if you see on that graph on the right, it says center of glide 114.6 and the bubble temperature. So these are all things that are very specific to that refrigerant at that altitude that are being calculated. And I can just say MeasureQuick is the only one that really does this type of calculations in providing this level of accuracy. Okay, so here's your summary slide. It's not the end, just to clarify, it's not the end. But digital just does better. That's just the way it is. There's so many things that we do now that are just digital. I mean, how many people have an analog radio in their car still, right? You know, who's turning the big knob or pressing the buttons? I guess I wonder how many people maybe not even know what I'm talking about that are on this webinar. So yeah, so this is where we're headed. The question is that can we make sure that these things are required by the states to make sure that you're getting accurate information? And I'm not saying you have to have MeasureQuick. You have to have accurate measurements. So there's multiple ways to get there. We work with a variety of different manufacturers in terms of all the things we do. You could use all of those probes you see there at the same time or mix and match them. So we're trying to make things very open for the industry. So it is a concert of instruments. You can't just depend on one measurement and think you're going to be able to make conclusions. You've got to be able to measure multiple things at the same time and relate them to each other. The temperature outside is crucial on how your refrigerant charge is working. Your temperature inside is crucial. Your static pressure, there isn't anything that really isn't crucial, but the goal is if I'm not measuring them all simultaneously, I can't tell when one thing is failing. So you can't just share probes and move them around as you want to do measurements and trying to keep track of them and write them down. That's just a destiny for failure. So our goal is to kind of use a lot of the stuff that the industry has out there. So on the next slide, you can see that there's multiple manufacturers, and this is only a small representation, but in general, most of them have an app that works directly with their devices, and they're giving you at least the details that you need in order to make educated decisions. Hopefully, many of them will step up and try and give you more calculations that are there. And everything's in your palm. This is what makes this really cool for people that are new in the industry. These younger technicians just find that here it is. It's staring at me in the face of what I'm looking for. What do I need? What are my issues? And that it's in your pocket. There's not a bunch of hoses to connect or figure out what do those numbers mean and lots of different things in the industry. So this is why it's so easy for many people to get in the industry early and actually adopt doing accurate measurements. So we're an app only. People keep thinking that we sell stuff, but we don't sell any of these products. We just work with them. We only work with people that we feel are providing very accurate, high level measurements. And then we spend a lot of time integrating that. We don't just like grab their measurements. We actually talk to their devices. We actually can get information back and forth, and we're talking to them. So we actually can sometimes change that device as how we're doing stuff. So we really are a full integration into a lot of different stuff that's out there, from electrical to carbon monoxide detectors, a variety of stuff that's out there. We really do a great job of just trying to make sure that you get accurate information, and we're confirming that the tool's also changing the modes if it needs to. Most of the stuff I had were really handheld, small stuff, but people don't think that there's actually one major smart probe or smart device that's out there that will change our industry more than anything we have. It's great to measure refrigerants and temperature splits and all that kind of stuff, but the one thing we're not doing very good is we're not measuring airflow, right? It is just something that we've kind of failed. Airflow also determines your charge. So most people like, oh yeah, the system's not working correctly. They run to the device outside, gauge up. We already know the issues there already, and then try to adjust everything through the refrigerant. It's a fixation in terms of like, I'm a refrigerant guy and I want to go outside and check refrigerant and actually change that. Not knowing it's the airflow that's always connected and actually determining those temperatures and pressures that happen outside and inside. So if you're not checking airflow first, you're going to find out that you're chasing your tail and you're putting refrigerant in and taking it out, and it's a disaster. So if we're not going to do a great job of measuring airflow, then we're going to fail at making heat pumps work because of the ducts that are already installed in the existing homes. I know that the TrueFlow Grid is working on an update for their app to try and help people figure out if this system will be adequate for my new heat pump that I want to install. Is this duct system adequate? This is a major game changer for people who are coming out to do sales, or a technician who's coming out to see what's going on with the existing equipment, to be able to measure airflow and feel confident that the existing ductwork will work or may not. And I need to talk to the client now about, this is a major upgrade. This is a different of sometimes $10,000 or $15,000 to change out ductwork. We now know, based on using a smart device to give us high confidence. So this is my filter box, stump box. It's to measure it, capture it, save the data. And when you save it to the cloud, you can export it. You can generate reports. You can do everything. It's, since I've been doing this since 2013, I've been shocked that we just do not write stuff down. We don't capture it. Sorry, let me correct that. We do write stuff down. We don't direct capture. Everything should have a direct capture. If you're able to measure it in a digital device, you should be able to capture it and share it with others. Thank you.
So question for the team, or whomever wants to take this. Wes, maybe it's for you, but what is the best way for high performance builders to convey the correct message to their HVAC installer that, yes, indeed, we do want the manual J, the manual S, the manual D. We want commissioning. We want an Energy Star verified HVAC installation. Is it in the scope of work documents that we send out to them at the beginning? Is it in our specifications? What from your side with ACCA is the best way for us to convey that message? Because I think there is, an awful lot of builders now that want this.
I don't know if there's a best way. I think that an attempt must be made and communicated. Builders are such shy, withdrawn folks. It's hard for them sometimes to exert themselves, I know. But even if it's just a conversation, specifications are great. I wish more contractors read the specifications through. Other performance documents, absolutely, or in the contract language. But whatever works. I would hate to say do this and it's going to solve all your problems.
Great.
Yeah, I'll add to that. Yeah, so let's not wait for. I have a builder right now who's in Florida and in the Carolinas, and they actually have homeowners gathering every Thursday to complain about their system, right? So if you want to hope that doesn't happen because you didn't do a good job of requiring this type of information, then you're just waiting for, especially when you're dealing with heat pumps, you're waiting for some issue. So it's not uncommon for contractors to mandate a variety of stuff about the quality they want. And if your contractor doesn't want to do that, then you should be curious as to why they don't want to do the best install. And it also is avoiding callbacks, warranty problems, comfort issues. These are some of the great issues that happens when your unfortunate envelope may fail. They're calling this HVAC guy. So that's really what you're trying to do, is figure out, what can I do to make sure that the HVAC system was properly installed. It is actually not the issue. We need to figure out what it is. It may be missing insulation in the attic or a wall or something. So let's try and make sure everything is done correctly from the start.
Wes, I think you had mentioned a search tool on ACCA certified installers. Can you share that in the chat with everyone?
Absolutely.
That'd
So
be
I'll
fantastic.
share both. There's a contractor locator and then the QA contractor directory. Absolutely.
That's fantastic tool. And I think we'd love to send that out through the EBA email list too, so that folks that are either on this call or hearing this on a recording can
It's searchable by zip code. So enter a zip code and you can set the radius. Absolutely.
Fantastic. And then, Joe, maybe this is a great question for you, but how much do our energy raters play in double checking this work? I think they're doing some testing on the commissioning side, but what's been your experience with that?
Yeah, it's a great question. So what we showed with the new ACCA workflows were really intended for contractors to keep them involved. I know that the whole program itself wants to make sure the contractors have a role, But as you know, if you're trying to get Energy Star and you're in a rural environment, that's already a failure. So the real standard that's coming, it's already there, but less people are ready to actually use it, is the 310 standard. The ResNet, ACA, IC, whatever, lots of acronyms there, but it's a 310. We will actually, as MeasureQuick, have a 310 that'll be out in January. And a lot of people are doing it now as kind of a manual process, but that's the role of the rater. And many raters were reluctant to do it. The challenge is I don't think they're given enough points for what they're really, the effort they're doing and what they're getting out of it. And depending on where you're at, you may only get 1 point or potentially 4 points. But I actually filed a grievance about that this is crazy that and what they disclosed was they're afraid of all of the data that already exists to say how bad systems are, that they just can't accept that all these systems they've just been accepting as being good clearly may only have a 30 to 60% accuracy in what they have because we're not testing them. So I think they're afraid of the truth, to be honest.
Understandable. Well, my hat's off to PNNL and ACCA and our friends at MeasureQuick for what you're putting together. I think, the data that you shared, Joe, on just the correlation of the amount of refrigerant leakage and what that means in terms of water or in terms of energy savings or in terms of CO2 emissions is really incredible. So our compliments on this happening in the industry. And Wes, all of us at EVA would love to continue to work with ACCA on, how we bring the HVAC contractors and the high performance builders together to make sure we're putting forth the best product. And then I think the other side of it is we always think, hey, we can design a high performance home, we can build it, we can do the manual JS and D and all the commissioning properly. But what's your advice on the long term? Because we hand this house over to the homeowner for operations. And I think some of us are thinking about, we're just going to build in a warranty with our HVAC contractor and say, you know what? They're coming back once a year for the next X years. What's your advice on that, Wes?
Yeah, I know when I was in the field, our business, that's with every new system, we always bundled in 2 years of maintenance. And it was at that time, pre-MeasureQuick, pre-performance testing, it was a little bit of an insurance policy too, right? There are some great tools. It's probably another webinar on system monitoring, and there's been a lot of progress towards monitoring HVAC system performance. It'll send off warning signs to whoever's logged into the system. But yes, we strongly encourage maintenance done correctly. Another ACCA standard is on maintenance, and we do not say twice a year or once a year. We say, let's start with one visit and then come back in this given period of time. Let's see, do we need to check this often, or no, we can stretch it out. Maybe it is a once a year. Maybe it's once every 2 years, whatever it is. But follow the standard, measure what needs to be measured, and make sure the system's performing as it should.
Fantastic.
I know you're going to end in a second, but I want to say thank you for EVA and you and Nancy, Aaron, for all things you guys do and bring to contractors and
Yes.
raters and everybody in the builder concept. You are a specialized group that's actually pushing people, and I think you need to. You have a great thing about EPA awards. I think we need to have an HVAC award, maybe starting next year, as the people that have actually done well with passing these types of highest grades. Let's give out a few awards so people know what this is.
Yeah, I think it's a great idea. I know that, I think that the problem is not acute in the southeastern or southern United States where heat pumps are prevalent. But I'll tell you that for some of us in the northern climates where heat pumps are not as prevalent, it's oftentimes difficult to find somebody that's well versed at this new technology. So, we're all trying to follow Zero Energy Ready Home program or the new Next Gen program, and you're trying to move on to more and more high performance. And I think we feel like, we want to be together with our HVAC contractor on what our goals are for the project. As you know, as Wes mentioned, we're a very shy group. us builders. So, but I think there's a real continued partnership there, and we would absolutely love to have you all back to talk more about that, because I think it's critically important as we move forward. Lauren, any final thoughts? Thanks for
No, thanks so much for
PNNL. I
having
mean,
us.
same goes. The great work that PNNL does. It's just an incredible team out there. And if you haven't looked at the Building America website, I mean, it's just incredible. But Lauren, thanks so much for your team for putting this STEP program together. It's critically
Oh,
needed.
I want to add to that, because
Yeah.
it has brought a major attention to why these tools are huge. So we appreciate everything they're doing to push this venue all across all kinds of different conferences.
Great work. Great. Everyone, thank you so much for joining us today. I look forward, Joe, I think you're going to be at the summit coming up.
Yeah, I look forward to seeing you.
I look forward to seeing you there. All right. Wes, thank you so very much. And Lauren, thank you as well.
Absolutely.
Thank you. Take care.